All right, and let's see what I can share. Okay, does this look okay to everyone?
Looks great.
You can see a slide. Okay, thank you. Yeah, so again, thanks everybody who's here. This is a repeat of a session that we did last Thursday, I believe, maybe 6 hours earlier or 10 hours earlier in some time zone. What we're going to do is to talk about FAIR and how it intersects with machine learning. And there's lots of questions about this. So oh, sorry, before I do that, I should say, yeah, so this hopefully is in the chat. If anybody else comes in, maybe somebody can repaste it in the chat, but it looks like we're still at the same 9 that we were before. We are an RDA meeting, so we're running under the RDA Code of Conduct. If anything happens that seems to be objectionable, please speak up and say that there's some problem. And if there's a problem with something I'm doing, then please report it to RDA. It says participants enter in listen only mode. Again, given the fact that this is being recorded, if you're happy to be recorded and you want to speak up, please do. I don't think it's an issue here. It's a small group and we'll just go through some stuff and we'll have a lot of discussion hopefully at the end. If you have comments, again, you can put them in the chat, but I won't necessarily see the chat until, actually, maybe I can see if I can leave this on the side of my screen and kind of see it. Yep. Raise your hand if you want to speak, or again, just speak up. Add comments to the collaborative doc. Most of the session will be kind of discussion. It'll be partly based on what people put into the doc. So hopefully that'll be good. And this is being recorded and it'll be available through the RDA site, I think, for some period of time for people that are registered for this meeting. All right, so let's start. What we're going to talk about here, and this is more or less right, but maybe not exactly, is kind of what is FAIR in general, a little bit on FAIR for research software. Fotis is not here because it's like midnight or 1 a.m. or something his time, so I'm going to do his part. And Silvio is also in that same, no, he's not in the same time zone, but he's also in a bad time zone. So we have a recording of Silvio. And then I'll do a last little piece, and then we'll have, hopefully, again, the majority of this, I hope, will be discussion. So what is FAIR? This is the bad version of the slide. Sorry, I forgot to change it. So FAIR, as probably a bunch of people here know, but I guess I'm not 100% sure, is originally started as a set of principles that were intended to ensure that data are shared in a way that enables and enhances reuse by humans and machines. And FAIR stands for findable, accessible, interoperable, and reusable. And for each of those letters, there's some set of guiding principles that are, I guess, things that we strive to get to, but don't necessarily actually always do, or aren't necessarily always able to do in practice. But these are the principles that we would like to be able to do that we think would make it most likely that data could be shared and reused. And I'm not going to go through this here in detail because I don't think it's incredibly important in this context, other than knowing that there are a set of principles for data. The principles also were intended to apply to other research objects that weren't data, both those that were used in research and those that are research outputs. Oops. Sorry, that didn't work very well. Give me a second to get out of this, or figure out how to get out of this. Sorry about that.
You're amongst friends, Dan.
Yeah, but it's still, I feel like if I had like a bigger screen, everything would be easier. Okay, here we are again. So the FAIR principles were intended to apply to all research outputs, as was stated in the original work, both those used in research and those that are research outputs. And the text in the principles often has this phrase metadata with meta in parentheses. And that's shorthand for saying the same principle applies to metadata and the data. So the data itself, as well as the data about the data. These FAIR principles in practice are not something that the dataset creator can entirely meet. The dataset creator has a role, and data repositories also have a role. And collectively, these two entities are responsible for creating and annotating and indexing and preserving and sharing the data sets and their metadata. And so then if we start to think about things that are not data, but are other objects, lots of other objects can be stored as data, but they're often not just data. They have interesting other properties. And for other entities, and these are things like, let's say, software, for example, or machine learning models, or documentation, or physical samples, or other things, workflows. The goals of making them findable and accessible and interoperable and reusable are mostly the same, but the details of what that means depends on the object, and the details of how they're actually implemented also depends on the object. And specifically, it depends on how that kind of object is created and used, how and where that kind of object is stored and shared, and how and where metadata is stored and indexed. And so we believe that there is work needed to define and implement and adopt principles for things that are not data, not just to use the FAIR principles as they are. There's other work that's needed, we think. So again, just to give some examples of some different work going on in a few different communities, there's work on making training materials and really other documentation FAIR. There's work on making computational workflows FAIR. There's work on making FAIR research software FAIR. There's work on making virtual environments FAIR as well. Virtual research environments, excuse me, or science gateways in some other language. So having said that, I want to kind of jump into FAIR for research software a little bit because it illustrates a bunch of the points about how things can be adapted. So there is a joint RDA, Force 11, and RISA, either working group or task force, depending on which organization we're talking about, called FAIR for research software. That group is coordinating a, thank you, Christine and Douglas, for sharing things. That group is coordinating a bunch of existing community-led discussions on how to effectively define and apply the FAIR principles to research software, as I was just saying. And then also how to actually achieve adoption of these principles. This group has mostly developed a set of FAIR principles for research software. It's gone through an RDA review, and we're just now in the process of trying to finalize the principles based on our responses to those review comments. We've also started work on some implementation guidelines and some adoption examples, and we're supposed to finish in March of next year, although I think it's going to be a challenge, but we'll see. All right, so that's where we are. The motivation for this, as I've said, is that software is not just another kind of data. The FAIR principles, as I've said before, were intended to be applied to all digital objects. But there are different recommendations. The recommendation from the EOSC practice task force says to recognize that FAIR guidelines will require translation for other digital objects, and here other is other than data, and that these efforts need to be supported. And the French National Committee for Open Science's Free Software and Open Source Project Group has a recommendation that says make sure the specific nature of software is recognized, and that it's not just considered just data, particularly in the context about fairness. So we have the draft FAIR principles that have been published through the RDA review process. And again, that will be updated hopefully in the next few weeks. I think we're going to try to get this done by mid-December. And we also then will be submitting a paper that will point to this and have some commentary about it. So yeah, so hopefully in the next maybe few weeks to months, these things should be out. Okay, so having said that, then what about machine learning? Right, machine learning models, machine learning processes are not software, but they're not data either. So where do they fit in? Again, this FAIR Practice Task Force from EOSC recommendation that the FAIR guidelines will require translation for other digital objects applies to machine learning models as well, and that's what we're looking at in this BoF, in this series of activities. The original FAIR principles claim to apply to scholarly digital research objects, but they really focused on metadata and data. FAIR for research software that I talked about, and also FAIR for workflows, focused on how to translate those principles for research software and workflows. But what do we do for machine learning models? Are machine learning models data? And you could think of a machine learning model as being a set of parameters and options for a particular machine learning framework, for example. Or are machine learning models software? Right, because software is compiled into an executable object that takes input and provides output. And that's effectively what trained machine learning models also do. Or maybe there's some combination of data and software and workflows, particularly if you start to think about a machine learning process or machine learning pipeline that includes training. Or maybe they're not any of these things and they're really something unique. And that's one of the questions that we want to try to work towards answering. As I've kind of said before, large elements of the FAIR principles for data are really dependent on archival repositories like Zenodo or other things that are in the re3data.org catalog. And these repositories are the place that actually hold the data or the metadata, usually both, and they provide the search and access capabilities. For software, this is not the case. Software is not typically shared via archival repositories. It's often shared through social coding platforms like GitHub or GitLab, or through package management systems like PyPy or CRAN. And so there questions come up about where is the metadata for these? How do you search them? How do you access them? And the answer is not the same as data. It's different, and it depends on which platform or which package management system we're talking about. And so if we think about machine learning models, do we think that machine learning models will be searched and shared via archival repositories, or potentially via executable platforms, or potentially through something else? And there's a couple of things. A deep learning hub for science is one, OpenML is another platform, and I'll talk about these briefly, but they're kind of two somewhat similar and somewhat different platforms for actually doing machine learning work or for sharing machine learning models. And then the last piece is that the models and training data really are linked intellectually. And so should they be linked as well in terms of how they're shared, or is that not relevant? And we don't necessarily care about the training data once we have a trained model, we just care about the model itself at that point. Okay, so where are we now? We had a poster at RDA VP 16. Which I will say was not a most pleasant experience. I think RDA poster sessions have gotten better since then, but I haven't unfortunately tried again from that experience. We had a BoF at VP 17 and repeat of the BoF. There was a FAIR festival where we did a talk on FAIR for machine learning models and had some discussion. In July, we had a community call with all the people that we invited from those three previous things, plus a bunch of people we found through Twitter and through other projects. We did a talk at a workshop called Demolus, which is something about linked data, and I don't remember exactly what it stands for, but relevant to this as well. And then we had a BoF last week, and we have this repeat today. And then next week we will have a BoF at the Supercomputing 21 conference focused on HPC aspects. So that's kind of where we are. We've been trying to build up community, build up interest, and understand what people think and where they potentially would like such an effort to go if they think there's a need for an effort. And so that's kind of what we're going to talk about here partly is where things are, and should we try to create a new working group or a new interest group? And if so, who would be interested in doing something, and what would the purpose be? What kinds of things would we actually do? Do we want to generate FAIR principles for machine learning models? Do we want to talk about a white paper about how FAIR applies to machine learning more generally, or something completely different? So having said that, let me just kind of wrap up a little bit of this part and say that we know of some relevant projects and stakeholders, and in the notes there's a place after the agenda to put in more that you know of. But I just want to mention kind of some of these things that are relevant here. So one thing that I previously mentioned are platforms. So DL Hub is a platform that lets you find, share, publish, and run machine learning models and discover training data. Keypoi is an API and a repository of ready-to-use trained models specifically for genomics. And OpenML is a fairly general system that lets you build open source tools to discover and share data, bring them into machine learning environments, build models, analyze results, and get advice on better models. There are relevant communities. The Pistoia Alliance is a group that is working through with industry a lot, trying to bring pre-competitive collaboration, and they have an interest in machine learning models. Elixir is a intergovernmental organization in Europe that is looking at life science resources, including databases, software tools, training materials, cloud storage, and supercomputers. And they also have a machine learning group, and we'll hear a talk on that in just a minute. And then CLAIRE is a confederation of laboratories doing AI research in Europe. And so there's also some interest there. And I'm sure there are more communities we should also be thinking about. In terms of projects, there's a couple of projects that I'll mention. One that I'll talk about myself is FAIR for HEP, which is using high energy physics as a science driver and developing a FAIR framework to advance our understanding of AI and applying techniques and exploring approaches. And then there's HPC FAIR, which is providing a generic HPC data management framework to make both training data and AI models of scientific applications FAIR, looking at program analysis and optimizations using AI and ML. And again, if you have other ideas, please let me know, or ideally even better is put them in the collaborative notes, because again, we really feel like if we're going to do this, we need to have as big a community and as diverse a community as we can to make sure that what we do is as applicable as possible and makes as much sense as possible. Okay, so having said that, I guess if there's any questions, we could have some questions briefly, and then I'll play the video from Silvio, and I'll do like a 2-slide talk about FAIR for HEP, and then we'll go into lots of general discussion. So at this point, rather than discussion, just if there's any kind of specific questions about anything that I've talked about, maybe it would make sense to try to do that briefly. So any questions?
And one question that I had, maybe briefly mentioned it before other people joined, which is the feedback you got from different groups. So you did BoF at different places. So what's the general feedback you got? Is that more 50-50% yes or no, or is resounding yes or resounding no?
There has been no consistent feedback, I would say. I think, well, sorry, I shouldn't say that. There's been consistent feedback that it would make sense to do something, but what that something is, there is no agreement on. So in one of the groups that we had, there was kind of a consensus that came together that said, looking at FAIR for machine learning models is too narrow, and there's many more things we need to do. So we think we should really write a white paper that talks about how FAIR could apply to the machine learning process. In the BoF that we had earlier, I think there was kind of a consensus that probably an RDA interest group would be a good thing to do around FAIR for machine learning models. And then that interest group might spin off a working group that might actually look at FAIR principles, but maybe not initially. Maybe there should be some general discussion first. And there's been some other things as well. So it's really been pretty mixed at this point. But again, let's leave that until let me do the 2 other little talks and then get into the discussion more, because I think hopefully other people will have opinions about what they think makes sense, and from their experiences what challenges they have as well and what they would like to address, or they may just be here to learn. So okay, so let me try to do this video and see if this works. Okay, I believe I'm going to be doing sound right, and this is about 10 minutes, but please speak up if anything seems like it's not working.
So the Elixir machine learning focus group was mentioned. First of all, I would like to say a few words about what Elixir is. Sorry, let me just, yes, okay. There you go. So Elixir is an international organization, and it's essentially centered around Europe. Currently has 23 member nodes, which are usually countries plus the European Bioinformatics Institute in Cambridge, UK. And the main mission of Elixir is to connect the national data nodes in the life sciences. So this is the main European infrastructure for life science data. And one of its purposes is to align the services from national Elixir centers in a federated ecosystem via common standard services. And it also provides the people and technical capacity to enable fair data stewardship within every European life science project. It's a pretty large endeavor because it contains almost 400 different teams spread across over 20 different countries. So yeah, it's quite large, and so far it has also been contributing a number of smaller projects to try to bring together the various components of the Elixir data nodes. The machine learning focus group of Elixir, in a nutshell, is essentially Jen Harrow from the Elixir Hub, who's the coordinator also for the tools platform, Fortis, and myself. And the goals of the machine learning focus group are, first of all, to define standards for machine learning, which is also what I'll be talking about for the rest of my today. Then also to contribute to benchmarking of machine learning tools, training for machine learning, the fair and reproducibility of the machine learning, and integration across different Elixir communities. So this is all centered around the life sciences, but it is pretty broad within that. It has gathered wide interest across many different nodes, and we have consistent participation of over 40 different members representing over 10 different nodes. And one major output, which is what I'll be talking about today, which are the DOME recommendations, which were just published this month in Nature Methods. And of course, also we are maintaining a connection to industry, in particular the Pistoia Alliance. So what is the problem with machine learning in the life sciences world? Well, first of all, that it has been undergoing an exponential growth. So you see here on this plot that the number of publications from last year, where you had the keyword machine learning plus something which is characteristic for life sciences, was on the order of 9,000. So there's a lot of publications in this particular field of machine learning. And one of the not so nice facts is that about 20% of the publications did not apply any evaluation to the methods. And even for those who did, usually it's very heterogeneous. So in a way, one of the dirty secrets in the field is that machine learning papers for bioinformatics can be highly problematic, and that many of the things which are submitted to journals are probably not well performed, or at least you cannot really gauge how good or bad they are, because the authors are probably not intentional, but are omitting certain key elements which would allow you to do a full technical evaluation. So hence, after a longer discussion, which is one of the things which Elixir is usually good at, to bring together various experts, we came up with a set of recommendations, which are called BOOM. And these are the recommendations for supervised learning in the life sciences. And these have the aim to improve the standards in this field. Now, supervised learning is still the most common case of machine learning in the life sciences, although it's by far not the only one, of course. And in any case, this is important to kick off also the discussion, and there's still a lot of work to do. So the DOME acronym itself stands for Data Optimization Model and Evaluation, which are the four main components we have identified. And you can see the analogy to the FAIR acronym here, certainly. The paper itself was published in the October issue of Nature Methods, and actually it has helped to kick off an entire focus in Nature Methods about machine learning methods. And how to improve their standards. So there's an editorial, interesting editorial in this issue describing it. So what are the 4 components of the DOME recommendations? Well, the first one, data, is related to spelling out clearly in the publications. And here we are always talking about how to improve the reproducibility and the trust you can have for publications. So what is the provenance of the data? How was the data split into training and test set? What is the redundancy between the different splits of your data? And finally, is the data made available? And here on purpose, we have not gone as far as requesting that everything should be available, because sometimes there may be reasons why this is not possible, but at least we ask the authors to specify whether it is available or not, so that then the reviewers first and the readers afterwards can judge whether this is appropriate or not. The second component here, the optimization, is really about the algorithm being employed, and something which is very relevant for bioinformatics and the life sciences in general is whether meta predictions have been used, because it's so much easier to get very good accuracy measures if you're already using other state-of-the-art methods. But in that case, you're probably not adding so much to the field, and so this should be spelled out clearly. Then it's some of the technicalities related to the algorithm. So how was the data encoded? What were the parameters, say for a machine, for a neural network or a support vector machine? What are the features being used? How was the fitting to the data done? And again, is all of this available for the users or not? The third component is the model. So here, something very important, which can trigger its own discussion, the interpretability of the model. So you probably know that neural networks are black boxes, essentially. So this, again, should be clear, because sometimes there are methods which are being enthusiastically described as being interpretable. But if you look closer, they're really black boxes. So this is something where the author should be stating what they are really proposing. And then the execution time can be important, because for large-scale applications, this is one of the main problems. And then finally, again, is the software in this case available? And finally, regarding the evaluation, first of all, is how was the evaluation of the method carried out? So what are the accuracy measures, for instance? How was the performance of the method on the various data sets? And a comparison to other existing methods should have been carried out, or it should be explained why it hasn't been carried out. Last but not least, it's about the confidence of the evaluation. So is it statistically significant, for instance? And once again, we also have an item about the availability of the evaluation, which can be important in order to make everything reproducible. So this is, in a nutshell, the definition of the DOME recommendations. As I said, this is meant for journal articles or even conference articles, if you prefer, but anything, in any case, publications. So what we are suggesting with the DOME recommendations is that all of these points could be addressed in a supplementary material table, where the points are clearly spelled out so that the reviewers first and the readers afterwards can have a clear idea of what is going on with machine learning and judge for themselves whether they trust the method being proposed or not. Finally, we have a website for this, with dome-ml.org. And there you can find more information about the DOME recommendations themselves, and also pointers to the current set of questions and how these can be answered and included as a supplementary table in the publication. With that, I think I've said all. So thank you for your attention.
Okay, great. So unfortunately, Silvio's not here, so we can't really ask any questions. But if there are any kind of questions, if we put them in a shared notes document and you put an address or some kind of contact information, I can ask Silvio and have him get back to you. Let me then do a shorter version of the other brief talk that we'll do about the projects that I'm working on, and then we'll go into discussion. And again, this will be shorter. So yeah, so the project that I'm working on, which I think is a kind of a nice example of people actually doing machine learning work, but also looking at how we should do machine learning work, is called FAIR for HEP, FAIR for High Energy Physics. And it basically is trying to combine high energy physics and the FAIR principles to build a world in which high energy physics world using machine learning has more rigor in its AI, has more data sets available, and has more models available, and really moves the community forward. So this is a US Department of Energy funded project under a program that is intended to create FAIR AI data sets and models for high energy physics. And so what we're trying to do is to automate the reusability of data sets by humans and machines, unveil new connections between data and models, and then accelerate the creation of domain-informed, rigorous, interpretable, reusable, and accelerated AI models that adhere to FAIR principles. And again, these are goals. I don't know that we're actually going to achieve all of these in 3 years, but I think we've made some progress towards them already, and hopefully we'll continue to. So what we're effectively doing is, as a project, we are creating and sharing high energy physics data sets in as fair a way as possible, and evaluating how fair they are, and helping to document what we're doing to make them fair in a way that hopefully makes other high energy physics folks able to better create and share additional data sets in a fair way. We're then using those data sets ourselves as well as others' data sets, and hopefully having others use our data sets to create physics-inspired AI models. We will be sharing these AI models through DL Hub, which I mentioned previously, and also using FunkX, which is a different project that a few of us also work on to enable people to run these models at scale in an accelerated and hopefully reproducible way to do work. And so just in the middle of the slide is an archive preprint that is describing the first data set that we've released, and again, the process by which we released it and the process by which we checked it and believe that it's as fair as it can be at this point. And this is also a paper that's under review and hopefully will be published in a journal in another little while. We got some minor feedback request, and we've made changes and just resubmitted, so hopefully we're getting fairly close to being accepted. And again, the intent of this is that the FAIR principles and best practices for sharing both data and AI models end up being well defined and embraced by communities of practice, and specifically the high energy physics community in this case. We think that this then could lead to new insights between the interplay for AI models and data. And we also think that having more AI-ready data sets available will lead computer science researchers to look at different computing paradigms that they can use, combining HPC platforms and edge computing, and making this all as easy to use for end users who are not computer scientists as possible. Okay, so having said that, there's a bunch of discussion questions. I'm not actually going to share them here because they're in the document. So let's say at this point, let's move to the document itself. And again, I will open this up. Anybody that wants to can please can speak up as they want. I'll try to kind of moderate and drive us forward to look at a few different questions in some order. But we shouldn't be limited by the questions we have here. Really, this is intended that anything that is interesting and relevant to FAIR for machine learning models, or even FAIR for machine learning in a larger sense, are things that we would like to talk about. So having said that, let me just look back over the chat and see what's been said there that we could mention. Let's see, so Chris had involved researchers doing machine learning, and as I said, I think that's great. And if anybody else has has projects that are really focusing that we should be trying to bring in, please list them, and we'd like to get contacts for those projects and bring them into this discussion further. Is there any other discussion about kind of that brief topic? Or Chris, I don't know if you wanted to say anything else either.
I just have some childcare background noises, so but yeah, I'd say it's really the one true interaction I've had is related to our data and software guidance, which does have some information about models, and that, you know, we were thinking about working with or just at least looking through that guidance with the and I shared the group's name, Radiant Earth, on here, that has an ML hub as well. So working through our guidance and working with them to see, you know, what else we could do to improve. And that, I don't know if I said the we here is the American Geophysical Union. So
yeah, thank you. So so we had a couple of people from that group that were I think they came to the VP 17 sessions that we had. And then we did a joint presentation at the ESIP meeting, I believe, most recently. So we have been in contact with them, but we probably haven't followed up as much as we should have. So that's good to keep remembering or keep reminding everyone. Let's see, Douglas, I don't know if you want to say anything about kind of connections into ESIP or AGU or any of the other science community that you're working with.
Yeah, I mean the earth science community, so mostly climates and satellite remote sensing. So what I'm also working with NOAA's data center here. And one thing we have been really focused on is on the data side, because like you have mentioned, the machine learning is not just the model itself, as links from the data to the data pre-processing, to the training, if we're using supervised learning, and then to the final like model itself, which can be compiled into a set of coefficients that's used in the model itself. So the model itself is basically a lot of those like coefficients to do all the weighted average of the input data and then generate output data. So I think when we are talking about FAIR, there are a lot of things need to be either we divide into granular to tackle it, or like do it in an overall phase. And low hanging fruit will be specifically focused on part of it. For example, the reusability of the model. I think that's what you're mentioning. The Radiant Earth has been working on the catalog of the model itself, because that will be itself is a simpler piece to do. But when we're talking about machine learning in general, one other concern I had is just because the development of machine learning and artificial intelligence in general is driven by computer science and has been developing really fast. And a lot of times when we're talking about FAIR, it also always goes to a metadata. And when we are trying to predefine some metadata that's suitable for the current development or current phase of it, and there are new things coming up already in the computer science field, that the metadata becomes less efficient. I would not say unusable, but they're less efficient and comprehensive to cover the future developments. So for data, it's less an issue, but for the model method itself, that becomes a problem.
Okay. Thank you. I'm trying to write a little bit of what you're saying. I'm not sure I'm doing it so well. So if you want to edit this in any way, please do. Any other comments from folks in terms of communities? Sorry, somebody was speaking. Nana?
Yeah. Thanks, Ben. See, I mean, I can see that it has merit to separate or decompose these ML models for the purpose of cataloging, and so it can be found or accessed and so on in the FAIR sense. However, could a FAIR machine learning model, which is very inextricably tied to the data and becomes very specific, does it have any, do you see any use outside the reproducing part of it through the FAIR paradigm?
Yeah, so I think this is this is an example where different use cases may be very different. So I'll answer this and then we'll go to Mingfeng next. So in high energy physics in particular, it seems like there are very clear places that a model can be built and trained and then can be used by a lot of people. And so one example is triggering on a detector, where you want to throw out events that you don't care about and just only save the ones you do care about, because the rate is so high you can't save anywhere near everything. I think another place is in astrophysics, like looking at gravitational wave signals. The idea is that models are trained and built, and then they're run across a huge amount of catalog data as well as in real time. So I think there are places that are maybe more observational, where models kind of get built and then they get used for a long period of time, and maybe in a few different experiments or a few different settings as well, or a few different sources of data, which might be different than people that are doing, let's say, simulations or some other things.
Sure.
So Mingfeng?
Yeah, I just reflect some probably experience or yes. So I do some little bit of research in natural language processing. So like a couple months ago, when I run machine learning model to classification, I thought really I have a virtual research environment locally on my computer. So I have, to run those classification models, I need to import data, and I just take a standard, models fitting my parameters. I took someone else's code and adapt that. So in the end, when I publish a paper, I have to have a detailed description of the process and that model and a parameter. So so I just wonder, is that publication be description of the model itself, or we have a separate, record about this model?
Yeah, I think that's a really good question that I don't know that I have a good answer for, other than that a publication is probably not going to be machine searchable or in some way. And so maybe it makes sense to have some kind of metadata at a high level that says something about the model, and then the publication is like the more detailed work about it. But I don't know. Do other people have thoughts on this as well?
This is Chris. I live in this world. So yeah, I mean, I would say that those are some of the challenges that we work with, as far as like transitioning to asking more of authors. So we do have like examples where we transitioned, and then authors still want to sort of cite a paper, but we're working with them to try and improve the sharing of other, of just additional material, like Dan is talking about. And I'm sharing, I guess this is a sort of direct link to our guidance on the model language. I'll share that link in our guidance for AGU authors. But yeah, it's expanding to include, as much as, at least for the moment, our focus is on software and data, but we've also seen sort of editors our community being more and more interested in sort of all the additional files associated with the model. So, but I hope that helps. Like that's our that's guidance that's gone through a lot of people thinking about models at the moment at AGU.
Any other thoughts on this before we go on to maybe Zachary next? Okay, so Zachary, oh, sorry, Francois, do you want to jump in?
Sorry, yes, sorry, I reacted late. I am not completely sure it's in this discussion, but in astronomy, we have a framework to share data, which is called the Virtual Observatory. And there are people who have developed a full set of metadata to share models. I'm not completely sure it's the same models you are discussing here. But if you are interested by this kind of metadata, it's I can put the reference of a standard in the chat eventually.
Yeah, that would be great. I mean, I would say rather than putting in the chat, if you can put it in the collaborative notes, so we have a
Yes,
record.
I can do both.
Thank you.
But I am not sure it's the kind of models you are discussing here.
Yeah.
It's not to train machine learning things, but it's to model phenomena, and I am not sure it's the same thing.
Okay, well, let's record it. We can look at it and decide later rather than deciding immediately if there's a chance. So let's see. So Zachary, you had put in a comment about, well, you can, I'll just let you say.
I'm Zachary Trout. I'm from NIST in the United States, and that last comment I think is a good segue into my question. I definitely love the idea of fair for everything, and I definitely see sort of fair for software being different from fair from data and potentially fair for models. And I was just curious if you thought about, do we need this dividing line between fair for ML models and fair for physics-based models? Has that been part of the past discussions in the various BoFs, and have you come to a conclusion on if ML models and physics-based models need to be treated differently? And I ask because the people in my team are combining the two and building models that bring in both physics and machine learning.
So Christine, do you want to say something? Please go ahead.
Sure. Yeah, no, I just wanted to respond to that. So I think that there's definitely value in using some of the established practices for how we keep track of models, machine learning or not, especially within a domain or within a project. But the reason that I think this BoF is interesting, and whatever becomes an IG or a working group, and while I'll stay part of it, is there are some challenges that are specific to machine learning, especially when you, not just for reusability, but how you document what you've done, how others can serve a follow, bless you. It is virtual, but we can still be nice to each other. And other things that I don't think we've delved into, like, are any of the ontologies and vocabularies that people have written for machine learning, is anyone using those other than the people that wrote them? Can we try and generate interest in converging on a few different things so that everything we build could be interoperable later? My research area is in studying the machine learning processing itself. And so I need the machine learning job data, if you will, and the descriptors about how it was done to be fair. And so there's these things I think are unique to machine learning and transcend the models. As well, I think it would be interesting to talk about, does openml.org do what is needed for sharing models? I guess it wouldn't if you're trying to keep all of the astronomical models together, not machine learning. But anyway, sorry, I gave you more than 2 cents.
Douglas?
I just want to follow up what Christine just said. I think in reality, I think the physics-based model, they can interplay with each other quite well because it's following certain physical laws. So you can interoperate or integrate them into each other easily. But for machine learning model, especially at least in my application of earth science. A lot of times the model I developed specifically, a machine learning model I developed specifically for one like variable in the entire system. For example, they are just looking at the wind speed, or they're just looking at radiation at top atmosphere, that it's hard for me to define what interoperability means for those type of applications, that I have a model that's for one specific component of this entire system, and how that interoperates with other components and how that can be integrated into the system.
Okay. I should say, Francois, I lowered your hand. I was assuming that it was still up in just from the last time, but if that was wrong, please raise it again. I didn't mean to cut you off if you had something else you wanted to say, but maybe we'll go with Nana now.
Sure. I mean, yeah, this is, I mean, I certainly second or third the idea of encompassing larger sets of models, including simulation models. But as Johan mentioned, that the simulation models are a lot more transferable, or at least or reusable than the machine learning models, as I mean, raised the issue earlier, which tend to be much more specific and in terms of transferability. Of course, once you build a model, especially in deep learning, model transfer is possible by adding more layer and retraining. That certainly makes sense. And in certain domains like yours, it makes sense to be, when you are looking at the same phenomena, it is possible to reuse and or use the same model to score the same phenomena. So in that sense, yes. But it is a subset of a broader modeling and broader models paradigm of how it is transferable. But it's also the harder part, if I would say.
Right, and I guess the one thing that I would maybe add, kind of to Zachary back on this question, is that I understand well, sorry, I shouldn't say that. I don't understand machine learning models, but I understand what a machine learning model is. And it's kind of a reasonably well encapsulated concept that I can kind of think about and think about how to deal with. I think the problem that I have is that physical models or even physics-based models doesn't seem to be a concept that means the same thing to two people. So sometimes models is simulation, sometimes it's sets of equations, sometimes it's something written that's an algorithm. And so I get a little bit confused about how to deal with it, because I can't exactly kind of wrap it up and think about it as easily. I don't know, like particularly in, I was involved in a NIH project called Multi-Scale Modeling Consortium. And in multi-scale models, they're ranged over a lot of different things. And most of them I wouldn't have called models, I would have called simulations in many cases. And so I'm sorry, I don't know if that's helpful or not, but it's the reason that I don't have a good answer for this.
And also, on top of that, then probably we need to differentiate the method and the model. So method or algorithm, for example, you have kind of established methods like a linear regression, k-nearest label k and so far. But when talking about model, it's very much individual research driven that bound with the parameters with that method. And also the result depends on the training data. So when we're talking about models, then probably we cannot it's not like a data. You can describe data by itself, but when you talk that models, then it seems it's hard to leave the research context. Yeah.
Okay. If anybody else wants to add anything, we can, or if not, I think we'll go to Graham's question about available and usable licensing, which I think is also kind of interesting. Okay, so Graham, do you want to maybe kind of say this verbally, and if there's any context for it as well?
Just going to remind myself what I wrote now. Just give me 2 seconds. Yeah, so I think kind of my general question was, you know, when you come to kind of the availability and of your code, you know, it's not just about kind of has somebody put it up on some sort of repo, but it's also, you know, what's the licensing associated with that? That's, yes, you can make it, you know, discoverable, but if nobody can actually download it to use it for that particular use case, then that's going to be a sort of a limiting factor anyway. That was just a quick observation. That's all. I mean, it applies to data, it applies to models or code, whatever. So that's kind of all my thoughts were.
Okay. I mean, so I guess the thing that I would say about that is that when the FAIR principles were being defined, they were very consciously defined to include data that was not open. And it's both, I guess, positive and negative, that anything can be fair, whether it's open or not, is probably a positive, and the fact that there's no encouragement of things to be open is probably a negative. And so I guess personally, I think we'll probably be in that same situation here, and I think we're thinking about that same thing in software, that that in some potentially ideal world, under some different circumstances, everything would be open. But in the world that we have, things are not open for various reasons, and we still have to kind of be able to work with them if we're allowed to. So
I'm sort of flagging up that it sort of touches on how you aid the sort of discoverability by allowing people to understand which code bases, which models are available for that particular use and which aren't. I mean, that just touches on a whole different area about kind of license classifications, which is beyond the scope here. But.
Let's see, so I'm just kind of scanning through old comments again and trying to catch up a little bit. I'll just mention for Francois' comment about, is there a disciplinary framework established by the HEP community to share its data? The answer is that I actually don't know if there is a disciplinary framework specifically, but there are some common practices and common services provided by Zenodo for CERN data. And one of the strange things about a lot of the high energy physics data is it's also not open. It's available to people in its collaboration, but there can be either some kind of a period where it's closed, or it may actually never be fully open depending on what's going on. So it's a little bit mixed, but I would say that there are very good practices for sharing within collaborations and kind of standards within collaborations, but not necessarily across collaborations or more publicly.
Yes, I was wondering, because we have, in astronomy, we have a data sharing framework, which is shared by the big observatories and by smaller teams and so on, which defines many aspects to make data fair, basically. So it's not dependent, and we practice open data, but it's not at the core of this discussion. Maybe we will discuss another day.
Okay. If there happens to be anybody else here that knows anything about high energy physics and wants to say anything, that would be great. It's not, I mean, I kind of play on the edges of it, but I'm not a high energy physics person. So.
I just work for a high energy physicist. I can't say I can add.
Okay. Okay, let's see. So going on, we have Michelle's comment about approach. Michelle, do you want to mention that a little bit?
Sure. I guess I'm jumping ahead to the last question. I'm sorry, I'm jumping in and out of this meeting today, and I might have missed some of the conversation you've already had. But just on this broader question of do you create a fair principles version for machine learning, it just might be useful to understand that the FAIR for virtual research environments conversation, which Christine is also part of, asked that question about 6 months ago before they set up their RDA working group. And the approach they're now taking is instead to think of it more as a toolkit, that there are already existing tools that are relevant to their community of virtual research environments. So how could they think about providing advice to VREs on how to use those existing FAIR tools for data and software, or but also then to think about where there's gaps, where there's the issues in fairness that are specific to VREs that aren't addressed by any of them. So that could be a useful approach here for machine learning, to acknowledge that some pieces are already in play and you might just want to contextualize them a bit for your audience, but there may also be other pieces where you need new work.
Okay, yeah, I think that is interesting to think about as well. I don't know, Christine, if you have any other thoughts on kind of from your side of this about that would help us in any way think about what we could do here.
Sure. Well, I've certainly enjoyed being part of the Fair for VREs, and actually we have a session the same time tomorrow. So if you want to head over there, there's your quick advertisement for that. You know, as Michelle, you know, I agree with everything Michelle mentioned. I think one of our key things we've been working on is building on the Fair for Research software. What's different about it for VREs? And I've wondered if we could also look at the gap of what's different for, you know, machine learning. I think VREs and this BoF have a lot in common in that you have to think through more of the workflow, because it's not just a simplistic thing of I have a digital object, I have this data set, or even I have this software package. There's inputs and outputs and different pieces of software. There's system files. There's ways that you're dividing up your data set. There's ways that you're validating your model. And so I think in exploring what the gaps are, we also might be able to give something back to machine learning and really thinking through the process and exposing some of the things that people skip when they do machine learning, or maybe fudge a bit because they're busy.
Okay, thank you. If sorry, I didn't actually write that down very well, but or at all actually. But if there's anything that you want to write in that kind of last bullet section about, is there an interest rationale to have a new working group? That would be great. Douglas.
I think I really enjoy how this conversation is going, because like Christine said, that there's a lot like pieces that linking together in machine learning parts as well. And when I was, again, still going back to think, what does reusability means for machine learning? And data is easy to define what reusability means, and research software is easy to define what reusability means. But for machine learning, are we talking, it becomes whether we are talking about the workflow of the machine learning process or pieces of the machine learning. For example, the data, the training data can be reused by other machine learning applications that they can use it, or are we talking about entire reusability? I think if we can separate them into pieces, although like in theory, we should not separate them into pieces, but maybe if we are thinking about more granular level, that it's easy to define so maybe overall, the FAIR for machine learning would be like different categories that the FAIR principles. And for some parts that the FAIR may be directly adopted from other parts. For example, FAIR for data, FAIR for research software, FAIR for virtual VRE, because machine learning development or the model sometimes requires specific setup that you need the virtual research environment, basically containerize everything, including the operating system, because that to make sure people can reuse that.
Yeah, that makes sense to me.
Johan, I didn't raise my hand, sorry. But I would sort of second what Johan said, and that's actually more of an example from a project I was on at the NIH, the Biodata Catalyst. And part of that project was to work with researchers that were actually learning ML in the, with NIH related projects, and they were trying to use platforms and tools across this ecosystem. They're trying to bring all these tools together, and one of the end results was to try and like describe how they their workflows, their what they did to sort of document the aspects of sort of cleaning, and then the actual machine learning processes that they had in place, and the way they would sort of document that was to be in the open, that was basically interoperable between the services. So the two big ones were Broad, Anvil, and the other one was 7 Bridges. And they had their sort of various platforms, but the idea was that would be shared between them, and that there was this place, doc store, to basically describe this. And it's a lot of what Johan talked about, all those pieces to document it. And the big part of that was, or the big challenge there, is that the researchers didn't have the training to properly document all these these workflows, and also the sort of inexperience with estimating costs, because all this stuff had to be in the cloud, using the various cloud providers that NIH contracts out with, like Amazon. And so though, I mean, really at the end of the day, it took an enormous amount of resources on our side, like that, just thinking about how that could be expanded in a sort of broader way to community, because it took a lot of resources for us to actually work with the researchers to document this all properly and publish it so that it was available sort of as a point and click kind of tool, although it wasn't, exactly, but like being able to take that and run it within another service was a tremendous amount of work.
Okay, thank you. So again, there's a few different questions in the document that we could talk about, but I guess I just wanted to also see if I think there's a few people that I haven't heard from. I think Dawn, Kevin, Carrie, Ian, if any of you have anything that you'd want to bring up, I don't want to leave you out of the conversation.
Ian here, nothing from me. I'm just listening interestedly because I think this is an interesting challenge. I think the closest we've come to this is thinking about data standards for crystal structure prediction, where a range of techniques might be used, some of which might be machine learning. So it's just a small part of it, but yeah, it's just knowing where to start to sort of try and capture what we want to capture. And we've got an example now where we're just going really high level just to try and get people as part of a sort of competition that's being run to provide something about their methods. But no way is it going to take us to a point where it's going to be kind of reproducible, and it will be a step towards fair, but it'll be a long way off. So it's just interesting listening to the conversation.
Okay. I'm sorry, Dawn.
I'd like to echo that. This is a learning process for me. The FAIR approach is new to me, so I'm learning. The program I work with works with a lot of heterogeneous data sets, software, computational artifacts. There are certain aspects of the work we do that overlap with machine learning. So it's not a central focus, but I would call it a peripheral interest at this point. So so this is very interesting for me, this discussion, is to put some of that work in context, and just it's learning for me as well. So thank you.
Okay, so Douglas, if you have a question for Dawn, then please go ahead. If not, I think Kevin was going to say something different.
Yeah, I will wait. I will wait.
Okay, so Kevin.
Yeah, I also just listening. I find this interesting. My area of interest is AI reproducibility and specifically sources of variability that go into causing problems with reproducibility. So, yeah, I've just been sitting here and just listening.
Okay, great, thank you. And Carrie also put a note in chat, which is similar in some ways. So very good. Yeah. So Douglas.
Yeah, I think the other thing to think about is that what's the impact of fair for machine learning might have, for example, driven the investment in the infrastructure, for example, because I'm in the DOE AI for Earth System Predictability workshop right now, and there are a lot of conversation about how to make sustained investments in data infrastructure, in computing infrastructure that allows the research community to access it, to enable the AI applications and development, and also the integration of that into the operation of the Earth system modeling and the impact-driven applications. So I think an aspiring goal of a fair for machine learning might be making to set a standard where the founders can make the investments to allow the researchers and the AI development to fulfill the fair principle. Like, because right now, maybe Christine have mentioned that some of the platforms may not necessarily work well if we have a really high standard for a fair. So maybe they need to have really a lot of investment in that part to make it possible for the researchers to share their models, share their code and data in a fair way.
Okay. So let's see, so there's about 15 minutes left in the session. I don't see anything else in the chat that we haven't really talked about. I don't see anybody that hasn't had a chance to say at least one thing, which is good. I think if I look at some of the questions that we were trying to address, I think we've already talked to some extent about what FAIR could apply to. And there's I feel like the consensus here is that for ML models, that's not necessarily the only interesting thing. And there's a lot of other questions about how FAIR applies to the whole kind of machine learning process. I will say that for me, and a little bit selfishly, I have this funded project that I'm part of. And what I said in the proposal was that roughly 2 years from now, we would have a set of FAIR principles for AI models. So I kind of would like to get to that point, but it's possible we won't. And it's possible that's not the direct thing that we need to do. And there are other things we need to do first, or other things that are more important. But I will say that, that I feel like our project isn't alone, and it is generating models, and it wants to share those models. And so I think one thing that I would like to try to figure out how to do from a group is to kind of be of service, so that as more and more models are generated, they actually can be reused when that makes sense, and they can be found. But again, maybe that's not the right thing to start with. So let's see, in terms of changes in definitions, there's a comment from somebody about the I of FAIR is hard, not just here. I don't know. I'm not sure who put that in, and if somebody would like to maybe talk about it briefly.
That was me. Yeah, I was just sort of flagging up that the interoperability issue is not just about kind of how you take machine learning components, but also it applies to data. I think there's just a wider conversation about what do you mean by interoperability. Do you mean the actual end result, the components, the data themselves, or are you on about kind of a slightly higher level of the interoperability of the metadata about those components?
Yeah, I will say that when we were doing the work with the FAIR principles for software, what interoperability meant versus reusability was extremely difficult to figure out, and we ended up kind of coming up with a little bit of an artificial separation of two concepts that kind of could be thought of together in order to do that. And so for machine learning models, I also have no idea. And I mean, to some extent, I actually am not completely sure that interoperability is incredibly well defined, even for data, but that's kind of me complaining for having not been involved in the group and not contributing. So shouldn't do that. Christine?
Yeah, so just for my own personal selfish needs, where I run into interoperability problems is with vocabularies. So for example, there are, so I'm involved in the Machine Learning Commons, which is an effort to do benchmarks for machine learning. It's mlcommons.org if you're interested. And so I use the system files generated, which use, some, I don't know, kind of standard libraries that capture some information about the systems that are running the benchmarks. But what some of those things have to be specified either from the hardware reports it back or the people running the benchmarks report it back. And they put in all sorts of crazy stuff. So if you try to aggregate or run machine learning on any of those files, it's really hard. And so for me, FAIR and ML, this is one of the things I'm working on. I don't know, not quickly, but not extremely successfully, but I can tell you I have interoperability issues myself.
Na, and then Mingfeng, and then we'll try to maybe get to the what we do next after that.
Sure. I think without full transparency or even the full disclosure or sharing of the data itself, the extent to which you could actually interoperate would become difficult with machine learning. And so on the other hand, the limited reproduction is possible if maybe some limited data is given and so on, or a container is created and then someone could actually reproduce. But beyond that, without full disclosure of everything, it would become difficult to think of interoperating in that true sense. But it's worth striving for. No.
And Mingfeng?
I put in document already, but I just briefly say that. So explainable AI and trustless AI is a hot topic nowadays. So that provenance in reusability, fair reusability could play a role here. So that could be topic to working on.
Okay. I think that makes sense as well to some extent, although, sorry, I've probably said this before, so if you've heard me say this, I'm sorry to repeat myself, but I do feel like that as much as we can divide up what we're trying to do into chunks that we can work on, the better off we are. And so just as an example, fair data, as we said before, doesn't have to be open. It doesn't have to be right. It can have errors in it. Right. Fair software can have bugs. Right. And so I think we have a lot of overlapping goals about what we want to be able to do with machine learning models, and I think FAIR addresses one part of them, and explainable addresses another part. Trustable is another part. Bias-free or understandable bias is probably another part. But I guess I'm concerned if we try to do everything, we'll do nothing, and so. I'm hoping that there's something that we can separate off in terms of the kind of the findability and the accessibility and interoperability and reusability part that's different from understandability, for example, or trustworthiness or even correctness. But that's, I don't know, that's just my opinion. I'm happy to be convinced that that doesn't make sense and we really need to work on these things together in order to make progress on them. So again, since we have a little less than 10 minutes left and we don't need to run up until the end because there may be other things people want to do, or like going to sleep in some cases if you're in Europe. I would like to try to just talk about where we go next and see. Michelle has put in her comment earlier, which I think is good about thinking about a toolkit potentially. Christine added to that. Francois talked about an interest group, which is something that came up in our previous meeting as well. I don't know, Francois, if you want to say anything of what you said, or we can read it.
I can just eventually say what I have written. In a sense, I think that there are plenty of things to discuss, and you seem to have people willing to discuss them. So this looks like an interest group, and the interest group can define precise aims for a working group, since, as you said, the working group is short term, as only it's 18 months. So I have a feeling after this session, and this is what you say from the previous one, that you can probably find enough people to build an interest group, and an interest group can also provide guidelines or products if in the end you find something which is useful to share with the community. But I have a feeling it's too early to build a working group, because you are still discussing what you want to do.
Okay, yeah, I mean, it's interesting that this topic, the interest group idea, hadn't come up until the session that we had last week. But once it came up, it seemed like there were people that were fairly strongly in favor of it.
Yes, I have a feeling it's also because there are people willing to work on the subject, but they are not sure how to do and what to do. And so this pushes for the interest group.
Okay. Christine?
Yeah, just from a practical standpoint, I think after you run a BoF a couple times, you might start to get a nudge from RDA to say, hey, aren't you an interest group? I don't know if it's 3 times maybe when you start to get, but that doesn't mean they wouldn't let you. But anyway, I do think that if you do decide to go for an interest group, put in the paperwork quickly and don't spend a lot of time on it, because I think it would be a shame to redirect too much of the creative energy towards the bureaucratic processes associated with that. But I think Francoise is right. There's enough critical mass to do it, and it's probably the right time before the next plenary. I don't know that you gain a lot by establishing working groups, because you can just work ad hoc, on things and recommend outputs, and then it saves some paperwork and time too. But of course, some people like the process, and I don't want to hold you back, but I just want to be a voice for, save the effort and do the minimal paperwork possible. But yeah, I'd vote for an interest group. I think also even just the people on this portion of the session, and then I saw the people in the last one, you've got critical mass, you've got people that could be co-chairs from the Global South, and some diversity of domains. And so I think you've got all the right ingredients.
Okay, well, thank you. I will say that in terms of RDA pushing for an interest group as opposed to another BoF, I'm very good at ignoring peer pressure. So that may not be an issue, but we'll see. But maybe an interest group does make sense. I guess the reason I think that we were initially thinking of a working group was to have a process and to have a deadline and to try to get something done in a fixed period of time. But there also has been a lot of discussion about other things. And again, one of the discussions we've had, not in either of these sessions, but in some of the earlier ones, was a collective writing of a white paper to try to define the scope of a problem better, and maybe to define some of the pieces. And I think that would actually help with some of the things that have come up here, but it's not, it's something that we could do as an interest group activity. It's not different than an interest group. So I think maybe this is where I'm leaning as well. So in the last 4 minutes that we have left, I guess the one thing that I would like to try to do specifically, in addition to just getting any other comments, would be if there's anybody here that would be willing to potentially co-chair such a group, I think that would be great. And if you could just add something in the document, again, that would be extremely helpful. The part of the reason that I say that is that the FAIR for Research Software group, we've had 9 co-chairs. Initially, RDA wanted to limit us to 5 that we could list on the site, and then it turned out that that was just the input form, and they were actually happy with 9. And having 9 of us has really been helpful because there's people in different time zones, and different people can work on different things and different parts of things. And that also then helps bring in like the networks of 9 people, which are not completely overlapping. So we get, I think, more buy-in and more dissemination that way as well. So, so my guess is that if we do something, that at least Fotis and I will continue to be willing to co-chair, but other people coming from other parts of the world, other genders, other nations, everything else would be great to get as well. I think it would be, again, we want multiple people, and we want diverse views as we do this.
Well, if I could just put a plug for people who are considering, I don't think you have to be an expert at machine learning to be a co-chair of this BoF. There's plenty of things that co-chairs do. A lot of them organization, or also being the person with the clear eyes who says this doesn't make sense. So don't shy away from it if you're really interested and you're like, oh, but this isn't exactly what I do. I don't think that matters. If you're interested and motivated, I think that's more important. And if you haven't been a chair before, it's actually can be really fun and rewarding, a good way to get to know your colleagues, often your country, once we're back to travel, but even for your virtual registration, often your country might have extra funds if you're a chair to help pay for your registration. So there, and I had travel paid for in the past as a chair. So anyway, just an extra plug to consider Dan's call.
And because I've learned that one of the most powerful things that you can do is to not talk. I'm going to not talk until somebody volunteers.
Maybe have the Jeopardy music going too.
I was thinking this will be kind of a depressing way to end with lots of good discussion, but nobody that wants to kind of help take the next step. But.
We can eventually put the videos on to finish the discussion. Just to say bye-bye like this.
Okay, well, if no one volunteers, we did have volunteers from the other side, so from the other session and from other things, but I just, I don't know, I just wanted to try to encourage people a little bit. And as Christine said, it's kind of a fun thing to do and to meet people and to learn some new things as well. So, so if anybody does, please put your name into the document. Douglas, for example, if you're willing, it would be great just to add your name to the document where we are now and where the cursor is, or anyone else as well.
And there might be this might be a way to draw people into RDA, because I know that Oak Ridge is really interested in this area, and so someone that works on one of the teams there, you know, might be willing. So we, like the other person said, asking around.
Okay. Okay. Well,
and then so you can ask RDA secretary to create interest group as a placeholder before you put a chart, so people can sign up. Then you can ask, you know, broader audience if they want to lead. Yeah.
Okay. Would you mind? Could you just jot something down in the document about that, because I wasn't able to do that. Thank you.
Yeah. They can create secretariat can create that before interest group is charted.
Okay. Yeah, if you could just jot down a note, that'll be helpful.
Okay.
Then Fotis will know as well, and I won't forget and get something wrong. Okay, so because we're actually a minute over, again, I want to thank everybody for coming. I think this has been a great discussion, And again, just kind of looking at Graham's comments, the Fair for Research software group was really good because we had people that were willing to lead, we had people that were willing to actively participate, and we had people that were willing just to review things and to comment on them. And we really need all kinds of contributions to be successful, I think. So so whatever you're willing to do and whatever your interest is great. And so with that, again, I'm going to say thank you to everybody who's here, and hope you enjoy anything left in RDA. I know there's a session Christine mentioned tomorrow as a plenary on a couple of days that I think I'm going to be going to. So thanks everyone.
Thanks for doing this, Dan.
Thank you.
Sure.
Thank
Bye.
you. Bye.
Thanks, Dan. Good session and worth staying up for.
Thanks all. Bye.